recording, and it is recording. Okay, cool. All right, today, you guys, let's talk about it. Okay, so objective, we're going to be solving exponential equations. Okay. So, as an exponential equation, let's write y equals ab to the x. I'm going to put a big box around it, okay? Y equals ab to the x, okay? So if I were to graph this, just a real quick graph, whatever the value of a is, that's where it crosses the y-axis. Has to be, because if x is 0, am I going too fast? If x is 0, right there, anything that's 0 power is 1, and 1 times a is a. So whatever this value is, that's where the graph goes through, okay? Now the base, if b is greater than 1, then it's going to be growth. Does that make sense? It's going to be growth. And it should look something like this. Just, it's going to be growing exponential, eventually curves up, right? On the other hand, if b is less than 1, then it's going to be decay. Like half of something, half of a half, half of a half of a half. It's getting smaller and smaller and smaller because the base is less than 1. So it's going to look something like this. Okay, that's just the general shape. Now, one of the things I do know is that if I keep going half of a half, half of a half of a half, it will never equal 0, right? So you have a horizontal asymptote there at y equals 0, okay? Because it will never reach 0, right? Never going to reach 0, so I get a horizontal asymptote at y equals 0. And the same thing here. On the other one, I'm also going to have a horizontal asymptote, because as x becomes negative, it gets closer and closer to 0, but it will never reach 0. So all an asymptote is just an invisible line, like an invisible boundary line. It's just a boundary line. That's all an asymptote is. Okay, it's saying, hey, you're never going to get to me. I'm an asymptote. Okay, let me say it again. Asymptote says, hey, you're never going to get to me. I'm an asymptote, because it gets smaller and smaller and smaller, but it never gets there. The only way you can get to the asymptote is to go to infinity. And when you get to calculus, we're going to go to infinity. But not till you're in calculus. Then we'll go to infinity, okay? And you're thinking, how can you go to infinity? Mr. Massey will show you. Okay, now, example 1. Let's graph it, okay? Got my graph paper. I'm going to go ahead and do a nice job graphing this, because I believe in high quality, right? No? You don't believe in high quality? I do. Okay. If I go by 2s, I can go by 1s. 1, 2, 3, 4, 5, 6, 7, 8, 9, and probably go by 10s, maybe 10, 20, 30, 40, 50, 60, 70, and 80. Okay, so I'm just going to do a real quick scatter plot. Go ahead and shift this down so you can see my data. So there's my data, and let me just do a dot to dot. So at 1, I'm at 81. At 3, I'm at 27. At 5, I'm at 9, right? At 7, I'm at 3. And then 9, I'm at 1. So if I look at my scatter plot, just try and connect the dots. What do you think? What kind of graph do you think that is?
I guess it is
decay. Decay. So we know it's decay. It's exponential. And I'm pretty sure it's decay, right? So if I have y equals a b to the x, right? Then could we kind of figure out what the decay is? or the equation. So, not quite sure what the equation is, and that's what we're going to learn in in example 2 and example 3. Okay, so not quite sure. So let's come back to this problem. Okay, I'm going to come back to 1 and figure out how to find this equation. Okay, because right now I'm not sure what the equation is. Okay, all right. So too fast? Did I whip it away too fast? We're going to come back to this. Okay, so let's look at number 2. Okay, so number 2. Let's go ahead and graph that. Put that down. And number 2. Let's see, I'm going to do a really nice job. High quality, right? Always high quality. Don't slop through things. 1, 2, 3, 4, 5, 6, 7. And probably go by 1, 2, 3, 4, 5, 6, 7. Okay. Do my scatter plot, right? 1 is up at 3. 2 is 1, 3 is 1, 4 is 3, 5 is 7. All right. What do you think? What's that look like? A parabola. Nice job, Saul. I think it's parabola. So if I were to sketch it in, I think it's going to look something like this. Okay. I think, just from what I see, the line of symmetry, boom, 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 you guys get line of symmetry? See, the line of symmetry goes right through the middle. You agree with that? So my line of symmetry is at 2.5. Right? My vertex, looks like my vertex is at about 2.5 and maybe 0.5. That's what I'm guessing. And I could come up with an equation like this. This problem we've done before, a problem like this. So how did we do this before? Well, vertex form, right? Slide it up. Okay, vertex form. Y equals a times x minus 2.5 squared plus 0.5. Remember vertex form? Okay, I'll revisit vertex form. Here's my vertex 2.5 and then about 0.5. Opposite, right? Do the dance, remember the dance, do the dance, squared. What's this? Now, there's some value A that we could find, right? If I want to find the value of A, I just have to have one of the other points. I can either take one of these points or I can take a point up there. You just have to pick one of the points. Or how about this point at 2, 1? That looks like an easy point also, right? So of all these points, which one looks like the easiest to work with? Probably 2, 1. You guys agree? So, and don't pick the vertex because that'd be silly, okay? But let's take the point 2, 1, and we can plug it in, right? So if I take this point at 2, 1, it's got an x and a y value. If I want to find the value of a, 1 goes in for a y. A times 2 minus 2.5 squared plus 0.5. So if I want to find the value of a, I have to pick a point on the curve, right? And so the point I'm going to pick is here, easiest point. I can pick any of them, but 2, 1's got to be the easiest to work with. So I plugged it in for a y value and for an x value. Okay, so then I get 1 equals a times a negative 0.5 squared plus 0.5. Okay, so 2 minus 0.5. 2 minus 2.5 is negative 0.5. If I square that, okay, so if I square that, 0.5 squared is what, a 6.625? I don't know, something like that, 0.5. Squared is a 0.25. I got 1 equals. All right, I squared this in my calculator. I got a times a 0.25 plus 0.5, right? I haven't lost you yet, have I? Minus 0.5 minus 0.5. I'm going to get an answer of a 0.5 equals a times 0.25. Just subtract, right? Okay, subtract, right? And now let's just divide, okay? Divide by 0.25, divide by 2.5, it should be 2.5 divided by 0.25 should be 2. It is 2. So a equals 2. Okay, so now I know the equation of this one. I do. I can go back and say, okay, my equation is this. I should have a y equals a 2, because that's the value of a. So I'm going to take my 2, plug it right there, right? Plug my 2 right there. So my answer is going to be y equals, there we go, y equals a 2, I'll put it down here, y equals a 2 times a x minus 2.5 squared plus 0.5, okay? All right, that was easy. We've done that. Now we still don't know how to find the exponential, but we're going to learn it in the next example, okay? All right, ready? Pretty good on that one? We've done that before. Now let's go to example 2, because if we can figure out example 2, we can go back and get the equation of example 1, okay? So let's take a look at example 2. So here's what I have. So exponential function, right off the bat. I know that. Exponential function, let's use this equation, okay? We don't need to graph it. Let's just do some algebra, okay? So start off with y equals ab to the x, okay? So let's take the 1, 6. So that's a point x, y value, right? So I'm going to take my 6 and put it for my y, okay? And I'm going to put my 1 in for my x, okay? So I plug my 6 in for my y and my 1 in for my x, okay? Now, this doesn't tell me much at all, but what I'm going to do is this. I got 2 variables, bummer, okay? I could then make a second equation with the other point, okay? If I have 2 variables, I need 2 equations. I've said that before. If you have 2 variables, you need 2 equations. I've said that before. If you have 2 variables, you need 2 equations. I know I've said that before, right? So let's do this again. Y equals ab to the x. But this time, let's plug in the 2 and the 12, right? So 12 equals ab to the 2 power, okay? How am I doing? Well, I still have 2 variables, but I'm going to go over here, and if I were to divide by b, I'd have a equals 6 over b, okay? How's that going to help? I'm going to substitute. How's that going to help? I'm going to substitute. So I'm going to take 6 over b and plug it in for a, okay? All right, so I get 2 variables, 2 equations. I'm good. I solve for a, so I can substitute over here. That's what I want to do. Okay, if I solve for a divided by b, I've got an equation here. So what I'm going to do is go now, 12 equals 6 over b times b squared, right? b over b squared, right? 12 equals 6b. You okay with that? I cancel the b for a b, right? You okay with that? Oh, this is getting easy. What's b? B is 2. So if b is 2, let's find a. Okay, I'll wait for you. I've got b. B is 2, let's find a. So if I put 2 right in here for b, a is 3, but I'll wait for you, right? So now, if I take my 2 and plug it right in there, correct? I'll have 6 over 2 equals a, and a is 3. So my equation, okay, I know a and b. I know a and b, right? So my equation, I'm supposed to have this y equals ab to the x, right? So now I'm going to write y equals 3 times 2 to the x power. Pretty slick, huh?
Slick.
Okay, let's turn the page. We're going to come back to example 1, okay? Ready to turn the page? All right. Oh, that shouldn't be a double parentheses, but hey, that's what happens when you're typing frantically in the morning, okay? Now we got some nasty numbers, but we can do this. You know why we can do this? Because we are smart. So let's start off right off the bat with y equals a to the x, right? I've got an x value and a y value, so I've got 3.6 equals a times b to the 2 power, right? Let's solve for a. Because if you have to solve for b, we're going to take the square root, right? Yeah, let's solve for a. If we solve for b, we're going to have square root. Not that you couldn't do it, but why would you want to do things the hard way? Are you with me? So let's divide by b squared, and I have a is equal to 3.6 over b squared. Okay, how's that? Okay, now let's make another equation. Y equals a b to the x, okay? All right, so I'm going to have 777.6 equals a times b to the 5th power, okay? I'm going to substitute. Am I going too fast or am I okay? So I'm going to substitute. I'm going to put this 3.6 over b squared right there, okay? Right there. So we're going to write 777.6 equals 3.6 b squared times b to the 5th, okay? All right, what do you see? Am I going too fast? What do you see?
B to the second and B to the fifth.
Makes up b to the 3rd. You guys okay with that? 777.6 equals 3.6 b to the 3rd. Correct? B to the 3rd, cancel, right? B to the 3rd. Okay, let's solve for b. What are we going to do? We're going to divide and then we'll cube root. We'll divide and then we'll cube root, right? So let's divide. Divide by 3.6, divide by 3.6. What is, I don't know, 777.6 divided by 3.6, okay. 216. Ooh, nice number. I'm serious. That's what my calculator says, 216. Okay, now cube root, right? Cube root. What's the cube root of 216? 6. It is 6. The cube root, 6 times 6 times 6 is 216. So b is equal to 6. Now, if you don't believe me, take the cube root of 216. Really? Say, okay, Mr. Davies, I don't believe you. Right, Jace? I don't believe you, Mr. Davies, right? I don't believe you. 6. I'm not lying to you. Not that I haven't. So if b is 6, let's find a. Easy, right? So a is going to equal 3.6 over 6 squared, right? Which is 3.6 over 36, which I think is 1/10, isn't it? Probably. Yeah. So I think I get a is 1/10. Okay, now we're almost done. So here's my equation. Y equals 1/10 times 6 to the x. There's my equation, right? Don't multiply those. Don't do those. Don't multiply because you really have to take the exponent first, and you can't. You really should take 6 to the exponent, but you can't. So you're done. Now, how about f of 4? Well, that's easy to plug 4 in, right? So I'm going to go y equals 1/10 times 6 to the 4th power. Okay, so I'm just going to do that. 0.1 times 6 to the 4th power, and I get an answer of 129.6. Okay? Okay, now flip it back. Let's go way back to the first problem, okay? So, all right, it's exponential. You guys agree? So let's go to our y equals ab to the x, right? So let's go back to number 1. Okay, so I need 2 points. Which 2 points? Any 2 points. Daisy.
5, 9, 7, 3.
You want those two? Okay, 5, 9, 7, 3. You guys okay with that one?
Sure do.
Okay. Can I like the 9, 1. Can I take these two, Daisy? Do you mind?
No, I don't.
You were totally okay with what you did. It would work, okay? I'm just going to pick easier numbers, okay? I like the 1, okay? So let's go. So we got 2 points, x, y. So I'm going to go 7, 3, and 9, 1, right? So the 7, 3, and my 9, 1. We'll do the same process. We'll go y equals a plus b to the x, right? So I'm going to go, okay, y equals, so I'm going to go 3 equals ab to the 7th, okay? Let's solve for a. Don't solve for b because then you have to take the 7th root. That would be silly. You could, but why bother? Let's just divide by b to the 7th. So I got 3 over b to the 7th equals a, okay? How am I doing? Let's make our second equation. 2 variables, 2 equations. Have I said that before? I think so. So then the other equation, let's go 1 equals ab to the 9th, right? We're going to substitute, put this over there. We're going to go 1 equals 3 over b to the 7th times b to the 9th. Sorry about the sloppy, that is a 3. Want me to white that out and make it look like a 3? Hold on, let's make that look like a 3, okay? So I'm putting this right there. That's a 3. Now it doesn't look very good. Now the whiteout's messing up my pen. All right, anyway, so I'm going to have a 1 equals a 3b squared. You guys okay with that? Okay, b squared, cancel, right? Divide by 3, I got 1/3 equals b squared. Okay. Square root, right? Square root. And so b is equal to the square root of 1/3.
4.577.
Yeah, but I'll leave it 1/3. Okay, so then I'm going to take and plug that in. So, okay, now it gets tricky, but we can do it. So, what's a equal? A is equal to, so I'm going to put it right there. I'm going to put it right there for b, okay? So I'm going to go, all right, 3 over the square root of 1/3 to the 7th power, okay? So, a is equal to 3 over, let's see, how can I explain this best to you? It's going to be a square root of 1/3 to the 1 power and a square root of 1/3 to the 6th power. I'm going to lose you if I'm not careful. Follow along. Trust me. Okay, this is going to be a 1, this is, okay, if I square it to the 6, 1 times 1 times 1, that's easy, that's 1. Now, I'm going to take 3 times 3 times 3, which is 27. Yeah, that's a good value.
Did you get 27?
Yep, I'm going to show you. I'm going to have to show you on the whiteboard. I need more room to do this, okay? I need more room, okay? All right. I need more room, okay? I need to do this, okay? I knew this was going to bother you, but you can do this, okay?
I'm running out of room.
Me too. I ran out of room too, okay? Okay, in fact, I'll stop the recording for a second because I want to show this. All right, it's time to do something.